Hi students, let's look at this question which is on probability. It involves P and C as well. So this question here was taken from 2013 paper 2 question 11 taken from the H2 Math A-level past paper. So a machine is used to generate codes consisting of 3 letters followed by 2 digits. Each of the 3 letters generated is equally likely to be taken from 26 letters of the alphabet A to Z. Each of the 2 digits generated is equally likely to be any of the 9 digits, 1 to 9. 0 is not used. Great. So find the probability that the randomly generated chosen code has 3 different letters and 2 different digits. Okay, so essentially what we need to do is what the required probability is basically we count the number of ways we can put 3 different letters in this case and 2 different digits, right? Over no restriction. I think no restriction is pretty okay. No restriction means you can just repeat the letters. So we have 26 letters and 26 letters and 26 letters, right? Then the digits are like 9 and 9. So that basically for the no restriction is just 26 cubed times 9 square. Okay, so that's that. So then after which what we need to think about is the number of ways which we could put three different letters here. That will be 26 multiplied by 25 multiplied by 24, right? Then in this case here we have 9 times 8. So this is 26 times 25 times 24 times 9 multiplied by 8. So I think that's pretty okay as well. So this should be your answer. It will be 400 over 507. Okay, let's look at the second part. Second part is essentially the second digit is higher than the first digit. Okay, if the second digit is higher than the first digit, we don't really care about the letters. We just need the 2 digits, right? So this is 100% of the time we'll put letters there. So you essentially just need to look at the way you place the digits. Okay, you don't need to care about the letters. What we really want is to figure out these 2 digits here. So for example, the second digit is higher. If I put, this is 9, the digit 9 is here. If I put 9 here, so meaning to say I could just put 1, 2, 3, 4, all the way to 8, right? So if I put 9 here, I've got 8. But if, say, my second digit is 9, so my second digit is 9, I have got 8 choices. If I put 8 here, I've got 1, 2, 3, all the way to the digit 7. Because the first digit have to be lower than the second digit. So if I put 8, I've got 7 choices. Okay, but then if I put 7 here, I have got until 6 as well. So I put 1 as a second digit, then I don't have any digits to go around because 1 is the lowest number already. We don't use 0, right? So 1 will be the lowest. We can't put 1 for the second digit. So we need this to be, let's say, 2. Then you have 1 choice. Okay. So essentially it is a case by case basis. We need to sum all the case here. The required probability is that the number of ways that we can over the number of ways no restriction. So this is it. I only consider the 2 digits, right? The number of ways second digit is higher than the first digit. We just sum. This is 1 way. This is 1 way. This is 8 ways, 7 ways, 6 ways, 1. So we just 8, then 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Okay. Then no restriction would then be, we have how many choices for the first one? 9 multiplied by 9. Okay, so just key in calculator, we'll get 4 over 9. Okay, 4 over 9 here. Great. So let's look at part 3. So let's look at part 3. Exactly 2 letters the same and 2 digits the same, but not both. I think what we could understand is this. Let's say this is A. A is exactly 2 letters the same. And let's say this is B. Okay, the required probability is essentially what we want to find is that if this is, say, a Venn diagram, okay, A and B, what we want is that this is A, this is B. We want this area here. We do not want the middle area. Okay, so the required probability is just part 3. Here's what I'll do. Required probability will be PA plus PB minus of rather PA union B minus of PA intersect B. All right. So we want to minus off the middle ones, but because A union B is PA plus PB minus PA intersect B. So we need to minus off the intersection of B and A twice. Okay, that's what I'll do. So PA plus PB minus 2P A intersect B. Great. So to find the probability of exactly two letters the same, so PA will be if two letters the same. I'll need to find the number of ways I can take two letters the same. Over three letters, no restriction. Three letters, no restriction will just be very simply 26 multiplied by 26 multiplied by 26, right? For two letters the same, what we need to do is we just need to pick it up. We need to pick this x here. We need to pick one letter to be xx, which is 26 choose 1, then after which 25 choose 1 for this y here. Then after which we need to multiply by the way you arrange them, okay? So the way you arrange them will be 3 factorial over 2 factorial. So that will be 26 choose 1 times that, which is 25 times, okay? Key in calculator, we'll get 75 over 676. Okay, that's PA. I think for PB is quite okay because two digits the same. You count the number of ways you can have two digits the same because we only run two digits, right? Two digits. So you can 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Every one is just 1. You count 1, 1, 2, 2, 3, 3, 4, 4. It's just 9 cases. No restriction for two digits will be 9 multiplied by 9. So it's just 1 out of 9, right? That's PB. Then whereas for the case where because we already settled P and PB here, now what we need to find is PA intersect B. P intersect B will just means that we need to merge both of them together. This happens to be independent events. Basically the choice, but it's okay. Even if we don't know, what we can do is we just take the three letters here. We do the same thing. You realize that the cases of choosing these three multiplied by these two here. So if say you want to have A and B happen together, you want it to be the two letters the same, then two digits the same. Okay, let's say KK, two digits the same. So like say WW. Okay, so essentially this case here will get we just need to multiply both because they are independent events anyway. The choice of the first one multiplied by the second one, they will not affect. Okay, so key this in, what we'll get is 25 over 2028. So here what we're gonna do is I'm just put all the values in. PA is 75 over 676. PB is 1 over 9. This is 25 over 2028. So they'll give us 1021 over 6084. Okay, that's it. Maybe I could label this as method 1. Method 1. For method 2, what we could do is we could just list down the cases that we need. Okay, so I'll just list down the cases we need. So instead of using the method 1, which we consider the Venn diagram, these are the three cases. You just list down the three cases that we need. I foresee that what students would forget is the two digits the same and three same letters. Okay, so for maybe I'll just count using PNC permutations. Just count two letters the same, two different digits. So 1, 2, 3, 1, 2. So two digits different will just be 9 times 8, right? This is okay. 9 choose 9 times multiplied by 8. Then this guy here, we need two letters the same, X, X, and Y, say. Okay, so firstly we need to pick the letters XX, so which 26 choose 1, then after which 25 choose 1, right? For this. Okay, so choose them first. 26 choose 1 times 25 choose 1. Then permutate XXY with 3 factorial, 2 factorial. Permutating XXY. Right? Then for the next, this is 9 multiplied by 8. You have 9 choices. Then 8 choices there. So I think this is pretty okay. Or 9 choose 2 times 2 factorial. It works as well. Okay, so this is the letter. So then after which we have two digits the same, all different letters. So we have already, we know that if you want two digits the same here, there are only 9 choices here. 9 choose 2, 9 choose 1. All right, so that will be 9. Choose 1 if you want to. So then different digits, different letters will be X, Y, Z. So that will be 26 times 25 times 24. So that's pretty okay. Now then the last one will be two digits the same and three same letters. Okay. Three same letters will be like X, X, X here. Then 2 digits the same will be W, W here. So I think this is pretty okay. What we do is this will just be 26 choose 1, or just 26 times 1 times 1, okay, times 9 times 1. If you want the times 1 behind, it works as well. So the required probability is to just add everything up, then divide by the no restriction. So required probability will just be what is required, then divide by no restriction with 26 times 9 times 9, okay? So the answer is also the same. You'll get 12016084. So these are two methods. You can just stick to either one, is fine. I think learn both will be good. The last one, we need exactly one vowel. Okay, so let's think about it. So vowel is A, E, I, O, U. We have like vowels, which are like 5 of them, right? Then the non-vowels, the consonants, 21 of them. Okay, so that's that. Then we have got like exactly one even digit. Okay, that's pretty okay. So we have got even digit. There are 4 even digits, right? 2, 4, 4 even digits, and then we have 5 odd. Okay, great. So exactly one vowel, but for we want exactly 1, 2, 3. So this case here, let's say if it's exactly one vowel, how we do it is because you could repeat, right? The digit can be used more than once, right? Yeah, I could repeat it. So this case here, I think what we need to understand is this, if you put a vowel here, 5, then one vowel, then 21 consonants and 21 consonants. But you must understand that vowel, consonant, consonant, the way to arrange it, right? There are 3 factorial over 2 factorial way of arranging it. So if you can have vowel, consonant, consonant, or consonant, vowel, consonant, or consonant, consonant, vowel, right? So that's that. Then the way to arrange this similar, if you want exactly one even digit, that would be 4 even multiplied by 5, but also multiplied by 2 factorial because you can swap the placement between them, right? So the number required, the required probability will be 5 multiplied by 2 factor 21 multiplied by 21, but you arrange the consonants. This is the letters multiplied by 4 even and 5 odd. Then multiply by 2 factorial because the odd and even can swap place, divided by the number of ways, which is 26, no restriction. Okay, and this will give you the answer. Check. So that will be 1225 over 6591. Okay, so that's how we do this question here proficiently. If you have any questions at all, please let us know and I'll see you in the next question.